Hey, live. Look at that.
All right, here we go. Okay. So thank you for coming to NC Ruby Meetup. Normally we start with Ruby news and then we get into presentations later. But since Amir is nice enough to come and meet us online, I figured we'd start with this. This is also being streamed over YouTube. If I put more thought into it, I would have announced that so people could watch this live. But this will also be recorded so people will be able to watch it later.
Yeah, I think the way it works is that after we're done, there's an option to actually post it to YouTube.
Yeah.
So just make sure to hit that option.
I will do that. Okay, so this is Amir Rajan. I like to think of him as one of the good guys. He's done a lot of Ruby work, .NET work, and I'm assuming other stuff. Your GitHub profile lists you as fun employed.
Fun employed, yes.
Unemployed. All right. So I guess I'm just going to hand it off to him and give us a presentation on a darkroom.
Sounds good.
Go ahead.
So I guess the way I was going to split it up was 30 minutes of. I think I'm getting some feedback.
Let me turn you down just a little bit.
Okay. It might be unavoidable, which is fine because if you turn me down too much, then no one can hear me. So I figured we'd do 30 minutes where I'd show RubyMotion, just kind of help you ramp up on how you could build an app using RubyMotion, and then we can spend the next 15 to 30 minutes, answering any questions, and all this information as far as how the app got to the #1 spot, information with regards to like revenue and what kind of reviews I was getting, market sizes with regards to different countries. All that's on my website, and so you can just go there and get a fully detailed account of everything that's happened with regards to the game. So does that sound good? Nods?
Yep.
Cool. So just a show of hands, how many are iOS developers or have done iOS development? One person? I see one person.
You got three. Four.
Three, cool. Four, awesome. How many are Ruby developers? More? Okay, that's good.
Pretty much everybody here.
Any RubyMotion developers? Anyone actually use RubyMotion? No one. Okay, perfect. This is going to be the perfect audience here. All right. So without further ado, let's get started. I'm going to share my screen and we can go at it. So I'm not going to be able to see any raised hands, so someone's going to have to talk and say that they have a question. Cool?
Yeah.
Sounds good. All right. Share. All right, y'all see that? Yes? Cool.
Yep, see it.
Awesome. So this is pretty much the agenda. I ported a Darkroom. It was a web-based game to iOS. It's clocking in now at about with iOS. It's a universal app now. So the iOS version, the iPhone version, and the iPad version together combined, it's about 15,000 lines of code now. And it hit the #1 spot in the App Store. It stayed there for 18 days straight, and I have no idea why. The short version is I have no idea why it hit the #1 spot. I have speculation with regards to what potentially would have happened had happened, but we'll go into that, I guess, the second half of the presentation. And let me just set my timer so I just have a good idea of pace. Is 30 minutes good for y'all?
Yeah.
All right.
Yeah.
Cool. Okay, I got my timer on. All right, so let's. So when I started doing RubyMotion, I actually started with, just to see the go. I actually started with Objective-C, and one thing that I realized, for those that have used Xcode, the language itself is actually pretty nice. The language itself is actually a pretty nice language once you get the hang of it. The challenge is that it does have its warts. For those that have used Objective-C, you guys agree with me? I'm assuming you've done Objective-C and Ruby. There are some nice functionalities with regards to the language, but as much as I would like to, as powerful as the language is, I still feel that Ruby has some benefits over Objective-C, and I'll show those benefits to you. So that's one thing that I saw. Another issue that I had was Xcode itself is a difficult IDE. It's a bit clunky. Coming from a .NET background, Visual Studio is leaps and bounds ahead of Xcode, and at the same time, Xcode isn't as lean as Sublime Text or Vim. So I have this middle of the ground IDE that doesn't provide the power that I'm used to, and doesn't provide the simplicity that I was used to. So it was just in a very uncomfortable environment to work in. From a language standpoint, and strictly from a comparison between Objective-C and Ruby, and then from an IDE standpoint. So given those two issues, I decided to build this game inside of RubyMotion. So RubyMotion itself, I think it's about, when I bought it, it was about $200 for a personal license. So it's not a lot of money, and it's very pleasant to actually interact with, and I'll show you that in action once we get to it. So that's kind of the spiel with regards to why I chose RubyMotion. Any questions with regards to choosing RubyMotion over any other potential framework out there?
Nope.
Let's have some questions with regards to that.
So here,
Yep.
not on the screen at all. I've sort of been looking at and like very passively reading whatever I can about Xamarin. So how about some comparisons to that?
That's a great question. So the question was, what kind of comparison with regards to why RubyMotion over Xamarin Studio and C#? So there's two main points I think that you need to take into consideration when determining what framework to use. So there's PhoneGap, which is JavaScript and HTML. There's Corona Studio, which is Lua. Then you have Xamarin, which is C# and F#. RubyMotion, which is Ruby, and then I think there's even something coming out for Haskell that can do cross-compilation to Objective-C. So the first question you have to ask yourself is that, given the knowledge of the team, what language would be the quickest to pick up? Okay, from a standpoint of risk, like, oh, is Apple going to, pull the rug from under us and just make it so that we can only code in Objective-C? That's not going to happen. There are companies and millions of dollars at stake for these languages, so I wouldn't worry about that. So the first question is, what is your team comfortable with? And if you're in a .NET shop, Xamarin would probably be your best option at that point. If you're in a RubyMotion shop or Ruby shop, Rubato and RubyMotion, Rubato is effectively JRuby and Android development. Those would be better options. Now, from a language standpoint, this is again, it's more of a observation that I've made. I won't say it's hard and fast, but I've found that Ruby and Objective-C are more compatible with regards to language features. So when you look at C# and Objective-C and you try to compare them, one of the things is like C# doesn't have the concept of optional interfaces. So you have situations inside of for those developers that have done iOS development, there are specific optional interfaces with regards to like table data sources and some UI view controllers that are delegates. Those options are you can create a class that has an optional interface inside of Objective-C. C# doesn't have that option, so you have to explicitly create another class and implement the interface through and through to actually wire up a specific delegate action. So C# doesn't have the concept of optional interfaces. It also doesn't have dynamic typing. So Objective-C, I would almost say, is optionally typed. It's statically typed. Most of the libraries are statically typed, but a lot of the open source libraries that are out there that I've seen have taken more dynamic approaches and message-based. So another thing with Objective-C is that it's primarily a message-based language too. You don't really call a method or call a function. You send a message to an object and receive a response. For better or worse, it's passing messages. So given that it's got these dynamic capabilities, specifically with the id, the pointer, the non-typed pointer or untyped pointer, and its the message aspects, I would almost say it even has a concept of eigenclasses or eigenclasses, and you can actually implement redefine methods in Objective-C. So there's some powerful things that are there that are more consistent with the Ruby programming language as opposed to C#. So that's just the observations I've made. Cool?
Yep.
Awesome. Any other questions? All right. So when I started with RubyMotion, the number one thing that you have to do is be able to map Objective-C code to Ruby. So if you can do that mental mapping, then suddenly things become a lot easier, and then you can leverage everything on Stack Overflow. So there were many times where I was struggling with Cocoa APIs and just how to do different things in Objective-C or inside of iOS. The documentation, I mean, the answers won't be in RubyMotion. They will be in Objective-C. But the nice thing is that with this crash course that I'm about to give you, you should be able to translate most Stack Overflow questions and implement them verbatim inside of Ruby. And so let me show you that first, and then we'll go into. So once we get the translation in place, then we'll go into how you can leverage RubyMotion itself. Okay. So here is Objective-C. Okay. So I'm going to go line by line, and then we're going to see what it looks like in RubyMotion. Is the code size good?
Yep.
Okay. Cool. So person alloc init. So this is a method call in Objective-C. Okay. Alloc is a class method. Init is an instance method. So person alloc returns is similar to saying person.new, and then init is a instance method on person. Person.firstName, this is a property. All strings in Objective-C have to be prefixed with this @literal. This retains backwards compatibility with C. For those Objective-C developers, if I mess up something, please correct me on that and help clarify. But so far, basically, you have first name, and this is a string literal. And then here's another property, last name, string literal. And then I call a C-based method called nslog, and call a method on person called sayHello. So sayHello is another instance method on person. All right, so keep that picture in your head, and this is the exact same thing, but written in Ruby, in RubyMotion. Okay. All right, so notice all the brackets go away. You're dealing with dot syntax at this point. So I'm still calling the class method, and then I'm still calling the instance method. The properties are the same. You lose the literals. You don't have to put that add prefix, and then instead of using brackets, you use the method here, and it's just dot sayHello. Parentheses are optional. You can add parentheses if you want. So again, the goal for this first part is to help you map. I spent a lot of time doing this, trying to understand how to map Objective-C code to RubyMotion. This is a way for you to just quickly be able to do that. Okay? So these slides will be online, so you can review the slides, but I'm touching the key points with regards to how do you translate Objective-C code to Ruby code. So if you notice, here's the Objective-C version, and then the Ruby version. So pretty much anything with a bracket becomes a dot syntax. Okay, so that's more of an API. So let's see how this person object is actually defined. So in Objective-C, here is the definition of person. Okay, so you have an interface. Person inherits from NS object. This is more of a contract, for lack of a better term. You have two properties, and then you have a method that returns a string called sayHello. The minus sign in Objective-C does not mean private method. It means instance method. So that was something that was a little surprising for me. I was like, oh, minus sign, it's private. No, it means instance method. So after you've defined person.h, then you can define person.m. And here is the actual method call right here. So NSString. So again, this right here means send a message. I'll use send message versus invoke method interchangeably, but effectively this is sending a message to NSString, and the name of the message is a string with format, and it takes in 3 parameters: the actual string format and then the array of parameters that comes after it. Okay, and then this will return hello Amir Rajan in this case. So that is a Objective-C class implementation right there. So we had the usage, here's 2 properties, a method, and its implementation. Okay? Here is a very familiar Ruby implementation. And this works, it just works inside of RubyMotion. So those two implementations you saw were equivalent. Okay, everything look good here? Let me...
Quick question.
Yes.
So can you go back to that Ruby example? I think it should show us more code soon, but I just noticed that you're using a different naming syntax, or convention, I guess. You say hello.
You can use snake casing if you want. I was just trying to maintain parity between the Objective-C and the RubyMotion version. So if you want to use snake case, that's totally fine.
So when you're doing these mappings, it automatically, like RubyMotion, will handle those details.
So as far as naming, you want to decide which way you want to approach it. So if you're going to access Cocoa APIs, most of the Cocoa APIs are title case or camel cased, and you'll have to explicitly call it that way. So there's no automatic mapping between snake casing versus title casing. But your own Ruby classes, you can make the decision of whether to make them snake cased or title cased or camel cased.
Okay.
Make sense?
Yep.
Inside of my code base, I used a snake case for all my classes, and then when I called into Cocoa APIs, they were camel cased. Any other questions? Did that answer your question?
Yeah, that did. Thank you.
Okay. Any others? All right. Moving on. So we saw how to execute a method. We saw how to define a class. This is something very unique to Objective-C, and I actually like it. The idea here is that basically in Objective-C, methods, the parameters of a method are part of its name. So here's a method with 3 parameters. So the way you say this method, you would say, oh, call the set DOB with month, with day, with year method. So all 3 of these parameters are actually part of the method name. Cool? And then this is how you would call the method here. So notice you provide each part of the parameters. There's no real commas in between. They just use the parameter name to do this. Okay? So we looked at using methods, creation of classes, and then now creation of a more complex method. And this is what you have here. Okay? So you're going to see a lot of code like this, a lot of the documentation. You'll see the name where it's just set DOB with month, colon, with day, colon, with year. And that's the full method name. And then the invocation of the method is done this way. Okay? So that's Objective-C, and this is the execution of the method. This is the same thing, but in RubyMotion. Okay? So set DOB with month, with day, with year. So it uses almost the hash syntax, or the Ruby 2.0 hash syntax to do this. And then the invocation of the method looks like this right here. And we're going to, at the end of this, I'm going to show you a Stack Overflow question, and we're going to put it all together just to make sure that everyone understands how you can mentally translate Objective-C to RubyMotion. Does that look good?
Yep.
So I'll show it to you one more time. So this is the Objective-C method. All right, your brackets indicate that you're sending a message. You're sending a message to a class instance, because it's a minus sign, right? And then this is the same thing in a RubyMotion right here. All right, so we're getting a little bit of a crash course on Objective-C, and then you can see what it looks like on the Ruby side also. So language parity you're going to find is very, very consistent. So here is a block. So Objective-C supports blocks. Basically, this is a part of a REST API, let's say, like a REST client. I have post, which takes in a dictionary object, toString, which takes in a URL, and then success with this mess here, for lack of a better term. That is a definition of a block that takes in a parameter and returns void. Okay? Madness. I know this looks a little crazy. So this is the execution of that. So inside of Objective-C, dictionary literals, again, they have that @ sign for prefixing. So you can do dictionary literals, but that's how it looks. Objective-C does not have a concept of symbols, so you just use strings for the dictionary literals. ToURL, that's a string, and then this is your block syntax right here. So the up caret followed by your parameters, and then the curly brace to define the block. So this is Objective-C. So we looked at methods, named methods, and now this is a named method where the last parameter is a block. And the way you would say this name is call the post ToURL success method. All right, so Objective-C, again, is a powerful language. It does have all the concepts that you would expect Ruby to have, or a good, quote-unquote, good language to have. It's just sometimes a little, it's a bit verbose, and there's backwards compatibility. There's concessions they made to make sure it didn't break compatibility with C. And some of these concessions you're starting to see right here, as with regards to how blocks are defined and arrays and whatnot. So these are primarily cosmetic things. We will get into like the specific things that make RubyMotion stand out. But this is the same thing, but with RubyMotion. So here's our object to post. We have that same dictionary syntax. And then this is the execution, right? So post, you have your dictionary array. You can use symbols, the ToURL, and then the success is a lambda. And you just give it, it will infer the type. Everything's fine there, and then you can execute your lambda expression. How does that look? Overwhelming? Have I lost anyone? Good. I saw one no. That makes me happy. Okay, cool. So, final thing. Here's your test. Okay. This is directly from Stack Overflow. So there was a situation where I had to figure out how to do an animation on one of my labels. Okay. So this is what I saw on Stack Overflow. So Objective-C underscore label. This is just a private method. I mean a private variable. Okay. So I want you to look at this. I'm going to give you a couple of minutes, exactly 1 minute to look at this and try to imagine what the RubyMotion code will look like. Okay. So we have our label. Here's some properties, right? This is an instance method. I mean a class method, and then this is a property on an instance. This is a class method with two parameters. The name of this method is UI animate with duration animations. This is a block with another completion block after it. So this one has three parameters. And then label, layer, background color, another class method, right there, right, and then property. So that's the structure of the Objective-C code. All right, I'll give it 20 more seconds. I'm not going to move. Everyone needs to think. Everyone's thinking. Everyone have their thinking face. I'll show it to you one more time. All right, ready for the answer?
Yep.
Wrong way, sorry. There you go. Okay. What do y'all think?
It's not drastically different.
Right? So, and that's one of the main benefits that I've seen with RubyMotion is that their APIs are one-to-one, and it's just ridiculously easy to take Cocoa APIs and then convert it to RubyMotion. I have had very little problem with doing that. Okay.
Yep.
So hopefully, you've gotten a crash course on Objective-C, and you've gotten how you can translate that to RubyMotion. So from here, you should be able to take every Cocoa API and leverage that inside of your RubyMotion application without any problems. Okay. So the question now is that what's the value add for RubyMotion? What does Ruby and RubyMotion bring to the table over Objective-C? And the value add is there's additional capabilities of the Ruby language that I really like, and I'll show off, and then the wrappers that exist that turn Cocoa APIs to idiomatic Ruby and Ruby libraries. So that's what we're going to look at now. Okay. So any questions with regards to translating Objective-C to RubyMotion? That was kind of like the 101 course as far as translating between those two languages, because that is important to know. So any other questions on that? No questions? Okay, we're good. All right. So now what does RubyMotion bring to the table? Okay. So one thing that RubyMotion brings to the table is the concept of opening a class. So that painful API that we saw in the Stack Overflow question, I can actually create I can open up the core UI view and then add my own methods to it. All right, so anything that implements UI view will get this method redefinition here. Okay, so now I can create my own extensions that are more in line with how I think about idiomatic Ruby. So instead of writing that crazy API, I can now just write something a bit simpler. So you can just open up a class just like you would inside of Ruby. All right. Now, Objective-C does have a concept of this opening of a class. It's called a category, but let me show you what that looks like inside of Objective-C. So that is the same thing that we did with RubyMotion. Okay. So Objective-C, you have to overload your methods, right? So I've created two instances of this, one that takes in a block and one that doesn't. You have the category name, so you define your interface. This piece right here is the category. And then if I want to use this category in one of my classes, I basically include the category, and then that specific object will have those capabilities. All right. So, and then here's the method. Here's the private method. Sorry. Here are the two private methods, one for animate and one for animate with block. So inside of Ruby, I can leave out the second parameter. I don't have to pass it in. In Objective-C, you have to provide both variations of it. Okay, so there's no concept of an optional parameter. So if you look at the RubyMotion version, notice that I have duration set to 0, or set to .5 as a default. No concept of default parameters in Objective-C, so you have to write two methods to effectively create the same thing, one calling into the other. Okay, so opening a class is nicer in RubyMotion, but can be done in Objective-C. So let's see how deep this rabbit hole goes. Okay, so that is opening class. What else can RubyMotion do? So RubyMotion has the concept of macros. Okay, so you can actually use class macros. This is actually code from the game, and basically here I've created some class macros that define some of the default properties with regards to some of the encounter. This is a RPG game, so there's battles that happen in the game itself, and these are title, text, and damage are class macros that I defined. And then when you beat the battle, you get loot. So you get fur, a maximum of 3 to 5, and then the chance of retrieving that fur is 100% in this case. So I'm leveraging class macros, and then you're also seeing the use of dictionary literals within the object itself. All right, so let's see what that looks like in Objective-C. Oh, so that's the implementation right there. Right, simple define method for each one of those. These are class level methods, right? Pretty standard Ruby. Okay, this is Objective-C. So Objective-C does not have a concept of class macros. So what you have to do is you have to actually define a dictionary that provides the definition of what the class macros in Ruby gave for you. Additionally, dictionaries cannot take in value types, so you have to box your value types in as NS numbers. And then same thing here. You have to box all your value types as a Objective-C object for them to stick into a dictionary object. So that right there, this is the definition for the Objective-C class, which was this here. Okay, so class macros are really powerful, and then the implementation is just as scary. So I have a class method, and then I pull out those attributes, and then I have to unbox the actual attributes with regards to the number, and set those values and define those properties as such. All right, so we saw dictionary literals, we saw the opening of classes. Here's class macros, something that Ruby, I took a lot of advantage of inside of RubyMotion. Objective-C has a compromise. You can use dictionaries, you can use different types of initializers, but the concept of a class macro isn't readily available. Okay? So a little bit more elegance with regards to the language itself. All right, what else do we have? Okay, testing. So for those that are familiar with RSpec, there's something called MacBacon that I know, right? MacBacon. And it's similar to RSpec. It's not it's not a perfect clone of RSpec, but it's got RSpec capabilities. And you get a simple testing feedback loop that's baked into RubyMotion. So when you create a new RubyMotion project, this is part of the test suite, which is nice. There's something inside of Cocoa. It's called Cedar. So there's what's it called? OC unit, I think, which is more of like a test unit type implementation. But there's also something called Cedar, which will give you a block RSpec-ish type usage within inside of Objective-C. But again, you again see the same noise, right? So the same literals. Here's your block syntax right here, before and after. So there was a lot of work to put into this testing framework to make it look this nice. It's just I'm glad I didn't have to do it. I'm glad someone else did this work. So if you are forced to use Objective-C, if you're continually using Objective-C right now, I'd definitely take a look at Cedar. Again, it's difficult to wire this into an existing project for those that have done Objective-C targets or targets inside of Xcode. It's not the most pleasant experience, but that's what testing looks like inside of Objective-C. So questions so far. So we've covered opening classes, class macros, and then the actual testing story and what that looks like between languages. Any questions on those three features? The only thing that I haven't been able to use inside of RubyMotion is the actual instance eval with a string parameter. So it can't interpret Ruby on the fly, but everything else that I've seen has worked very well. Everything from mix-ins, modules, opening classes, redefining methods, inheritance hierarchies, all that has worked very well for me. Questions?
Yeah. So when you're using RubyMotion, do you just use Ruby normally and just expect it to work then?
Yeah, it's really good about that. So one thing is that just because it's Ruby doesn't mean that you have all the Ruby core libraries. So there was one situation where I needed the observable module, and I thought I would just mix in observable, and then I got a compiler error saying that it couldn't find that module. At that point, I just pulled in the source for observable into my code base, and then used it, and it just worked at that point. So I wouldn't you can't just use Ruby gems like just out in the wild and expect them to work on iOS. But as far as the language features themselves, all those work, and then for those things that aren't available, you can actually pull them in. A lot of the enumerable modules are already baked in, so you get all the find, filter, search, where, sort by, all those things are readily available to you. But observable was one of those situations where I actually had to pull in the source for that. Did that answer your question?
Yeah.
Cool.
Thanks.
Any other questions?
We're good.
All right, cool. Okay, so the final piece. So this is one of the first views in the game. Very simple view. It's one button on inside a navigation controller. Okay. This is what it looks like inside of Objective-C. Okay. So you init the size of the frame. You initialize your room controller, which is this class here. You set up a navigation controller, alloc init with room controller, with root view controller, which is this one. You set the root view, and then your view shows up. On the view did load, you set the title, you set the background, you initialize your buttons with a specific size. You add a target, which is the click event, so button clicked for control event UI touch up inside, and this is button click. So this is using Cocoa APIs. This is Ruby code, but it's using the Cocoa APIs. So if you went on Objective-C and said, how do you wire up a navigation controller, this is the code you would end up seeing right here. Objective-C code converted to RubyMotion. Okay? So you can do that. You can take Cocoa APIs and just verbatim do a conversion into RubyMotion. And I would actually recommend starting that way just so you get a good understanding of the Cocoa APIs and their architecture itself. But at some point, for me, it was really soon. I got to the point where I was just tired of writing this kind of code, a lot of this boilerplate code. So this is where the RubyMotion wrappers come into play. What happens is that a lot of, if you go to, I have the URL, but there's a rich community of open source wrappers that makes Cocoa better to work with. So while this is plain old Cocoa code, this, what I'm going to show you now, is using two libraries. It's called they're called Bubble Wrap and ProMotion. And this code right here is the same implementation. These two things will generate the same view. So instead of so here's the app delegate. App delegate is the entry point in your application. So this is the Cocoa APIs. I'm sure all of y'all are squinting trying to see this. Right there. And then that same thing is represented by this right here. Okay? And then ProMotion is the UI, is a wrapper around Cocoa. So this concept of a screen is still a navigation controller. You have access to all the core Cocoa APIs, but they've just made it nicer to work with. And so here we're using Bubble Wrap. So instead of the add target to wire up the event, we can use a more idiomatic Ruby approach to wire that event up. So here was the wire event, right? You have the add target, and then the actual event call here. And this is core Cocoa APIs. If you Google how do I programmatically wire up a button, you'll get the Objective-C implementation of this. And then, but inside of RubyMotion and Bubble Wrap, it's this followed by a block that you can provide. And there's many libraries, many libraries that wrap a lot of this really nasty code here. So just to show you the libraries, RubyMotion. There's a wrap for that. So there's 2 years ago, I would have been hesitant to using RubyMotion because it wasn't better enough, right? The Ruby language itself is nice, but there weren't a lot of these wrappers out there. But now there are. There's a significant number of wrappers out there. For those that are currently doing Objective-C, there are wrappers for AF Motion. That's a very popular REST or HTTP client or HTTP library. There's wrappers for that. There's wrappers for all kinds of form things. Plus, you can use CocoaPods inside of RubyMotion applications. So you leverage all the open source out there for Objective-C, and additionally get these nice wrappers. So one wrapper that I've seen it's a wrapper around core data that actually makes it look like Active Record, which is pretty nice. The ones that I used inside of the game were Bubble Wrap and ProMotion. Those were the two primary ones. But there are a ton of wrappers now available that definitely, put it to the next level, take RubyMotion to the next level. So those are the key points that make it much better. So out of the box, and I'll show you this real quick. Out of the box, build, test, and packaging. You can use Objective-C libraries via CocoaPods, and then it's got a pretty good open source ecosystem on top of that. Cool. So I want to show you like just a hello world RubyMotion app. But before we do that, any questions? Any questions with regards to like the RubyMotion wrappers? Value add, opinions on the value add that RubyMotion brings?
I guess I have one question.
Mm-hmm.
And I don't want to make it sound like I'm disappointed, but it seems like, I don't know, like I was expecting a drastic change, and it's just from hearing about RubyMotion. But it seems like it's, if you get to use Ruby and it makes it, it cleans up some of the ceremony around the code.
Mm-hmm.
But like, can you think of like the most drastic change where it's like one line of Ruby, or you pass a block to something that, converts into, 15 lines of Objective-C? Are there any drastic things like that?
Yeah, I think so good question, and it's a very valid observation. So if you find that your iOS app is predominantly view-based and Cocoa-based, the benefit of using RubyMotion significantly lessens. The more UI code you have in your application and the less like domain and business logic code that you have, the less of a reason you have to use RubyMotion. Now, when it comes to the domain logic and the actual plain old Ruby objects, the biggest benefit I've seen have been all the block and the Lambda, the innumerable extensions that are included with inside of RubyMotion. So there's a library out there called m_, which is similar to _JS. It's called _m, that tries to bring some of that block syntax into Objective-C. But what I've consistently found over and over again with regards to just domain, plain old Ruby objects and interacting with like those backend APIs, I've seen significant benefits with using RubyMotion. I can show you an example. This is part of some of the. So here are examples with regards to the block syntax. So describe. I'm using blocks here, right? So find all, sort by first. These variations again, it doesn't come outside of the box with Objective-C, and every implementation that I've seen with regards to some of these more functional based or these fluent interfaces just does not it's not up to snuff with regards to the clarity that I've seen with RubyMotion. Same thing with dictionaries. I've been able to leverage a lot more of the primitive dictionary object with regards to RubyMotion. I would not have done the same thing in Objective-C. I would have probably ended up creating classes for that kind of stuff. But that's primarily it. It's kind of a death by a thousand paper cuts. So you start making taking these small concessions throughout your code base, and then you find that you've written a lot more code, Objective-C code, than if you did RubyMotion. But again, it's that question of, is it better enough for what you're doing? And I think it becomes less better the more UI code you deal with. Does that answer your question?
Yeah, Tim, if this is a right way to look at it, you said it's the code base is now up to 15,000 lines of Ruby. I've found Ruby to be a very concise language. Like, it can do a lot in a little bit. I guess it makes more sense to me because, like, when I first saw even 12,000 in the title, I thought, well, gosh, with 12,000 lines of code, you can do a lot in Ruby.
Yes, it's a massive game.
Yeah, but the game's not that complicated, or it doesn't seem to be. It's not like you're just a 3D game or something.
Yeah, a lot of the complexity. Have you beaten the game?
I have, anybody?
Someone's have? Yeah. So there's a quite a. Let me give you the line breakdown. That might actually help. CLock. So the UI code is, if we look at, let me go into the actual app. So this is a Cocoa code. All right. So there's 3,000 lines of Cocoa code. Doing this in RubyMotion, you probably, or doing this straight in Objective-C, you probably wouldn't lose that much, right? You might write a few hundred lines of code more in Objective-C for the Cocoa side of it. Okay?
Okay.
Now, with regards to the engine, and these are all good questions. Okay, so there's 6,300 lines of engine code. So this is backend work and and whatnot. Different aspects of the engine. I showed you lines of code to do effectively a lot of the map navigation, and quite a few uses of blocks, ordering of different arrays, a whole lot of dictionaries right here. Set piece events. This is where I used the class macros. So if we look at encounter events here, so a lot of class macros were used to define these structures. Significantly more code in Objective-C if I did this in Objective-C. Plus, I wouldn't leverage the dictionary primitives as liberally as I do inside of my RubyMotion code. So again, more classes to delineate these different kinds of constructs, just because it's not as fun dealing with these primitive types here. So a lot of things like that pushed the envelope a bit more. But it's a lot of these like just little things that are in there. If I had to guess, just stick my thumb out there and say how much more code would this have been, I could easily say it'd probably be 2,000 to 3,000 lines more code in Objective-C if I did it that way. So it's not a lot, but it's significant enough to where it wouldn't be as fun to deal with. Another thing is primarily the actual tests themselves. So the feedback loop is extremely nice with regards to testing. So let me show you a more complex testing rules of events. So here I'm using RSpec style tests where I have a different set of arrays of testing, different variations as far as random dice rolls and whatnot, and then I'm using an RSpec style language here, just to say apply all these test cases here, or all these types, apply these test cases to those specific types. So the feedback loops all in place. I can go in and do rake to build out my simulator, to run the simulator right here. It does come with, when you're in the simulator, you have access to IRB. So it's got a in-memory REPL that you can actually use to try to figure out what different parts of the application are. So I can go in and say, okay, I'm going to click that. So now I have access to the UI button here. So I can do self and see the UI button. I can do self dot red and actually see it update inside of here. Let me try one off the frame is equal to CG rect make. So there you go. See the light fire button just kind of went to the top left-hand corner. So you can actually change. You can actually change the UI as you work with it. So there's the light. It's right there in the corner. Let me do a more drastic change. 140. So just different REPL abilities like there. So there you go. It's moving around as you see it work. So those kind of things make it nice, and then I can having access to the REPL, saying, what options I have available, self-dot methods. You get all the introspection abilities there, and whatnot, and then you can call any of these methods during runtime and then perform whatever actions you have. So similar to, I'm not sure if you can do that same REPL inside of Objective-C. I may be wrong on that though. What do you think? It's a question of, is it better enough? Personally, if the next project I'm going to do is going to be RubyMotion. I mean, I have very little reason to go back to Objective-C outside of the team dynamic, right? If the entire team understands Objective-C, then that's an obvious data point that you have to consider when doing this. What do you think?
Seems alone the REPL would be enough for me to make it to do a lot of styling on the fly.
Yes. Yeah, and I've heard the argument is like, well, we just use nibs, but a lot of the more complex applications, they're so much more dynamic with regards to like the UI layout, and it's almost storyboards have collisions as far as merge control or source control, merge conflicts. Nibs have the same issue. So I've seen more of the seasoned developers use programmatic construction of views, and at that point, that feedback loop is significant. Being able to use the REPL to try to work through this stuff. Any other thoughts, questions?
You've been talking primarily about building an application from the ground up, and whether you want to use Objective-C or RubyMotion for that. Suppose you already have a Ruby web app out there, a Ruby on Rails web app out there, and now you want to put that to a mobile environment. Do you get any benefits by taking that Ruby on Rails application and moving it using Ruby on Motion, or are you basically starting all over from the ground up on that?
The primary benefits you get would be out of your plain old Ruby objects. So if they use like active active record or active model or application controller, you won't be able to move those classes over because those modules don't exist in RubyMotion. But if you have like simple libraries that actually do the validation for you, like on the server side, could you leverage those on the client inside of your RubyMotion application? Absolutely. Right. So it's just a matter of what dependencies you're bringing across when you're building your RubyMotion applications. Another thing that you'll find is that if you're familiar with HTTP client, like doing REST API calls, you'll be immediately familiar with the wrappers that exist on the RubyMotion side. So the learning curve involved with using, let's say, RESTKit or AF-Motion just doesn't exist for you, because it's just consistent with what you expect with HTTP client on the inside of Ruby core. So plain old Ruby objects, you can definitely use all those, and then just idiomatic Ruby, it'll start making a bit more sense with regards to the wrappers that exist now. And I would go through the wrappers that are out there. You'll find quite a few that are very good at RubyMotionWrappers.com. Did that answer your question?
Yes.
Yeah.
You mentioned Sublime. Did you say you use Sublime?
I use Vim, but you can use Sublime Text. They come with CTAG files for all the Cocoa APIs. So if you type in rake tags, that will come up with the CTAG file. On top of that, all the running the simulator, deploying to the App Store, packaging your app for deployment, instrumentation, all those things are available via rake. So you don't have to worry about any of theplists or what have you with regards to iOS development. So like here's my rake file. So as far as all the properties that I can define, they're effectively just rake file settings, and then RubyMotion handles the creation and the packaging of these rake file settings.
And what about the debug model? Do you debug on your simulator first, and then push it on the device
There is debugging support. I have not used. I have personally not used the debuggers. So RubyMotion does have step-through debuggers for on the device and inside of the simulator itself. I just haven't used them. I would imagine it's similar to Pry or ByBug or Rails debugger. So all those variations out there. But you are giving that up. The Xcode debugger has a richer experience because it is an IDE, and you get the debugging capability directly from that IDE. So you are making a concession on debugging at points.
Okay.
Any other questions?
Would it be possible for us to see the game? Just
Yeah.
for those who haven't seen it?
Yeah, let's do it.
And you're sharing your screen right now, or your camera.
Yeah. Thank you. There we go. Okay. I'm going to turn on. This is spoilers. All right. So if you haven't played the game yet, divert your eyes. All right. And you don't want the game spoiled. Please divert your eyes.
You're not giving the ending away, are you?
I'm not going to give away the ending, but there's going to be some cool things that are given away. So I'm going to click my little final stage button. There we go. We're in the final stage right now. Okay, so it's an ugly game. Okay, it's a terrible looking game. I wish I could say that. I wish I could say that this game was pretty, but it really isn't. So this is part of the game. So I'm using scroll view controllers, a lot of progress bars. Let me go to the more complex parts of the game. Equip some cured meat. Waiting for this embark progress bar to complete. So the first part of the game is fairly simple. I mean, the amount of code there is not a lot. The world.rb, this is what you're going to see as soon as that progress bar fills up. The anticipation. There it is. Okay. So here's this is actually like an ASCII-based map that's generated. It's crazy, huh? NetHack style map. So let me see if I can actually get into a battle. All right, here's a battle with a gaunt man. Isn't this game silly? Everyone's wondering right now, is like, how is this #1? How did this ever make it to the #1 spot in the App Store? So this is part of the game, and you can loot and take pieces of equipment and stuff, and then head back to the village. So this is an ASCII-based map. This is a primary part of the game here too. So a bunch of. I'm sorry?
I was just going to ask, would it be possible, and I say this just as someone who's played the game a little bit, can you show us the beginning of the game?
Sure.
I think that might make it a little bit more sense to see it from the start.
So here's the beginning of the game. So you start off by lighting the fire, right? So at this point, some people left 1-star reviews and said this game is crap, it's a scam, there's no way, he gamed the App Store, he's a criminal mastermind. And so eventually, you start seeing, so it says, a stranger stumbles through the door and collapses in the corner. So then you see these buttons show up, and then you start, going to these buttons, say, okay, well, gather wood, and then you start getting story elements with regards to what's happening inside of this world that this game has created. So the stranger in the corner stops shivering, her breathing calms. So there's an NS timer loop that goes in and updates the game loop. It's a great battery saver. So because it's black and white, I think people have said that it's almost as good as being on standby while they play the entire game. So you start gathering wood, and then you start getting supplies. And it's like, okay, well, I have some supplies. This is in debug mode. That's why I have 2,000 supplies now. But then you start building different aspects and start building up your village. And then you start building huts, and then eventually when you go back, you're going to start exploring the game. And then you get additional things that open up slowly as this world is created for you. And for the person that's played the game, it's awesome, right?
Yes.
See? You
Well,
hesitated.
it's different. I played the iPad version, and I'd say the iPad version, it's a little easier to see.
Oh yes, yes. So
all
the
the elements.
right. So the cool thing was that as far as making the universal app, all I did was create a common a module that had like the core components, and then just created the iPad version, mixed in those core components, and then the same thing with the iPhone version. So I just used mix-ins to create the different variations, but the core engine and then the core UI components ended up staying the same. So that really helped also. But there you have it.
You may have a question.
Yeah, I mean,
I've got another question here. So I've never played the original game.
the web-based version of the game. Okay.
Yeah. So I'm wondering, how did you port the game itself?
I got a snapshot of the JavaScript code and then I re-implemented it.
Okay.
Yep. I thought about using PhoneGap. That was another option. I chose at that point. It was I didn't want to write JavaScript, and the existing JavaScript implementation out there was very difficult to pull that apart and just have it work on iOS. Like the touch and it just wasn't touch friendly, and to rework the JavaScript code, it was almost better to just reinterpret it. And that also helped with there was also a licensing issue. Of course, the original developer of the game gets royalties with regards to everything that I've done, but just to make it perfect a perfect cut, I also did that to protect both of us from any kind of potential copyright issues, even though I got permission from the original creator to do it. So strategic from a litigation standpoint, plus I wanted to do it in Ruby. So any questions on the App Store itself, like revenue? I'm very transparent with regards to all that stuff. We can quit whenever if y'all want to just disappear. That's fine too. I can't stop you.
But you had said that you said another RubyMotion for developing Android or JRuby. So
yeah, it's Rubato.
Have you thought about porting this then, or?
Yeah, it's in the works right now. It's in the works right now. So the engine, all 6,000 lines in the engine, just work. So now it's just a matter of creating the front end. So we have two options there. We can write the front end in Rubato, or we can compile RubyMotion down to bytecode, the engine down to bytecode, and then just reference it inside of the Java application. So you have options there, but Rubato it hit 1.0 a couple months ago, and we've been very happy with the engine conversion so far.
Is there anything that it doesn't do that RubyMotion can, or have you found any discrepancies, pain points?
No, it basically comes down to that mental translation that you have to do. So what we did with Objective-C in Objective-C in Ruby, you have to do the same thing with Java and JRuby. So if you've done JRuby before, you kind of have that, you know how to do those translations. So that's consistent. But as far as the plain old Ruby objects, it just works. So I was very happy with that. Any questions about the App Store?
I guess one.
Okay.
I've only deployed one app to the App Store. You mentioned at the beginning that let's say there's concern that Apple wouldn't let these kinds of apps in.
Right.
Is Apple able to tell a RubyMotion app from an Objective-C app? Or?
It all compiles down to with the new implementation of Ruby. With RubyMotion and with iOS, since iOS 6 and iOS 7, all of this compiles down to LLVM. So unless they really try to detect specific signatures or some smell or footprint or fingerprint, they really don't care, because it's all compiled down to native LLVM, and then two, they're making revenue off of these apps, so it's in their best interest to let these apps in. Monotouch does the same thing. It all compiles down to LLVM, PhoneGap, Corona Touch, even the Haskell cross compiler, all compiled down to LLVM. So I think that's what really helped the cause right there. Was that new compiler?
All right, thank you.
Any other questions? A little bit of, I guess, tidbits. With regards to like the revenue I'm bringing in, if I did it by myself, if I was a sole developer of the application, then I took a year sabbatical to do this, just to play around with different things, and this was just a random smash hit, I guess, for lack of a better term. So if I objectively speaking, if I just took the cash flow with regards to doing contract work, iOS contract work versus being #1 in the App Store, if I did it myself, I'd break even right now, 1 year later. But I didn't do it myself, so I am technically in the hole. So there's not, surprisingly, even if you're the #1 app in the App Store, there's not much money to be made, surprisingly. So don't build apps for people and let them pay you to. So don't try to build your apps. Just bill out and build apps for others.
In-app purchases.
Yeah, we thought about it. We thought really hard about having in-app purchases, but I think that's what helped the. Wait, there was a joke. What did I miss?
Like you can pay for color.
Yes. We actually thought about doing that. We thought about having like different font schemes. It's like you can have Courier New throughout for $1. But we decided against in-app purchases and ads too. Those are concessions we made just to maintain the integrity of the game, and I think that's what helped it get to the #1 spot. I think if we did in-app purchases or ads, it wouldn't have been as successful. So this is a complete oddball. I think that's why it's doing so well. But from a revenue standpoint, when we made it free for like a couple of days from our promotion, just to promote the app, and we got like 10,000 downloads in 2 days. It was just ridiculous. The paid version got 100 downloads a day, and then the free version got 10,000 downloads in 2 days. That's kind of the order of magnitude you're dealing with when you go from premium apps to free applications, or vice versa. So I can definitely see why there are so many free apps out there that do in-app purchases, because you just reach such a wider audience. People just don't like buying apps for some reason.
So how many people working on this, and how long did it take you?
So I was the only one that worked on the RubyMotion version. I learned RubyMotion while I did it. So if the first time through, it took me about 4 months. Knowing what I know now, if I didn't know anything about the game, but I had the expertise in Cocoa and iOS, it probably would have taken about a month or 2. So it's still a lot of code to churn through. And Objective-C, it would have probably taken about the same amount of time, but you would probably see a balder person here. Tearing my hair out.
Well, I think we wrap it up there.
Cool.
I really appreciate you coming online, giving us this talk.
Yep, and then on my website I have the full developer log as far as everything that's happened, when it spiked, what marketing I did, for those that are interested. It's all online.
All right. Thank you, Amir, for
cool.
All right, and I'll see you on Twitter.
All right, see ya. Bye.